Welcome to a crash course in circuit theory. We will continue with the simplified microcontroller model. In the previous video, I mentioned that the microcontroller can be used as a voltmeter and as a power supply. We completed the discussion with the power supply. Now we will move on to using the microcontroller as a voltmeter to complete our design. Recall previously that we had a basic series circuit which consisted of two components, the switch and the potentiometer. These two elements allowed us to control the output status of the lamp. In the previous video, we discussed that the microcontroller can be used to substitute as a substitute for the switch, where we write a program to determine whether the switch is open or closed. And this is done in programming. However, we would like to actually have a way for the user to control the switch themselves directly. This is where the input of the microcontroller can be used to detect whether a switch is open or closed. We recall that the voltmeter can sense levels of voltages, and this could be used to detect whether a switch is open or closed. If we look at this circuit, this is very similar to the series circuit that we had before, but this time we have removed the load and replaced it with a basic resistor. But it still will function in the same way as a digital output, whereas the voltage at this point will be 0 if the switch is open, whereas if I close the switch, the voltage will be connected to the power supply. The voltmeter inside the microcontroller can detect these levels, and if it detects a level while the switch is open, it will read it as a 0. We can pass that information on to P0.1, which it will give the command to open the switch. Likewise, when the switch is closed here, then the voltmeter will read that value as a 1. And that 1 can be passed on again to P0.1, and that will allow the switch to be connected to the power supply. Let me demonstrate this operation quickly. In this example, I have closed the switch, which means that the voltmeter has read this as a 1. The 1 has been passed over to the output, and the switch is connected to the power supply, which of course will operate your load. If the switch is open again, then that 0 is passed on to P0.1, and this opens the switch, or the switch is now connected to ground. And of course, we know that if a circuit is connected to ground, there is no energy. And without energy, you will not have an output. So this demonstrates the complete control circuit, which is very similar to our manual control circuit. But now everything is controlled by the software. Basically, what I've done is I have taken the status of P1.1 and assigned it to P0.1. So whatever the status of P1.1 will be copied over to P0.1, which controls the position of the switch. And that makes a complete control circuit. And that could be used as your starter circuit for your senior project. Thank you.